Hello, Derek with DGA Tech here. Today, we're going to go into basically how I like to set up a new Linux system. So, we'll create a directory here. Well, we'll open it as root first. I do not edit this video, so that way it's as informational as possible. Because when you're starting off with Linux, seeing someone else do it and include all the ways they do it, including the parts that seem irrelevant, may help them with the process. So we'll start by creating a new folder. We're going to pretend this is the root directory. We cannot name it that, but we can rename it to like basically r/d maybe, or yeah, there's certain things you cannot name it. So we'll just call it test. Okay, so in your root directory, there's going to be some pre-existing files. For example, if you go to file system, there's all these files. Alright, there's really not very many you need to think about when you're a new user to start off with. So say you've just installed Linux, right? So you go to your root directory where there is, for example, all your default directories. And the first thing you're going to want to do, because you'll probably not be into the terminal at first, is you'll want to create a root directory like this, right? Now, this can be a directory where you store all your little projects, and it's at the root directory, so it has root access privileges, right? This is where you can compile kernels and stuff like that. If you're a new user, integrating with the existing system is not going to be as streamlined as creating a new folder and doing it your own way until you can learn how to integrate into the existing system. Because that way, you create your own kind of mental database, set up how you want to, that you reflect on your computer, and then once you have that complete and your understanding is deep enough, then you can integrate all that information directly into the root file system like a lot of people do. This is a way to strengthen your understanding of Linux slowly and create a strong foundation for yourself. So, for starters, Linux is case sensitive. So you have your dev directory by default, which has all your devices. If you ever need to repair your Linux installation, you may need to chroot, and a lot of times in chroot, you have to mount your dev directory in order to be able to do certain things, along with some other stuff like your sys directory, your proc directory, and ect resolve config, right? So, each one of the things we're going to do is going to represent parts of that process. So first off, in your dev directory here, you're going to also want to create, well, you won't need to create a folder for this. It should already be there. That's going to be your home directory, right? And in your home directory, you're going to have your user folder. In my case, it's that. So we'll create a new folder, and this will just be called user, because this is the user. So this is, and inside of your user profile, you're going to want to create a new folder, and it can be called applications, right? So far, I mentioned when you chroot, you have to mount your dev, you're going to have to mount your sys, you're going to have to mount your proc, and you're going to want to mount your ect resolve config, right? Which will give internet access. So now that you've done those things, now is where the fun starts. Inside of dev, you can do custom mounts. So say for example you open up a terminal window. We'll clear this one so that way it's just there. You're not going to be sued into it, so we'll exit out of that. Alright, so say after we encounter terminal, we're going to want to su space, and it'll ask for a password. Now, most likely, if you freshly installed Linux, this password, you will not know it. So you can press Control on your keyboard, and then press C. It'll exit out of su. It'll undo it, so you don't have to enter in that password that you don't know. But sudo, you will know the password to, right? So you can sudo, and it tells you how to use it. Really, all you got to do is do sudo, and then passwd, and then root. If you were to do this, you can change your root password, right? So you'll enter in the password for your user when you log in. Since you freshly installed Linux, you're probably the admin. So there you go, and then you enter in your new password. It's recommended it is not the same as your other password. I intentionally mismatched them so it did not change my password because I already have this set up. Once you have done this, you can type in su and enter in your other password that you just set. And once you do, you've logged into your system as the root user. Now, when you log in as the root user, there's another directory on here that is your root directory, and it's literally this one right here. Right, so you go into that, you're going to need access privileges, you're not root. But you can, once you log in, you can ls, and it'll show where whatever's in your home folder. But if you go cd squiggly line, or also known as tilde, then it'll set you to the root directory of the user that you're logged into terminal as. Why would you want to log in as su? It's simply because you have root access privileges, and that means you can do anything on your system within reason, although please note, you might break your system if you do things iffy. So make sure you have your installer so you can reinstall if you mess something up beforehand, and make sure that this is a fresh install and you have time to reinstall if you mess something up, because using Linux is a learning process. So anyways, at any rate, you've got this here. And so once you have set that up, you can ls, and you see everything in the root directory, which we could not access by double-clicking it without entering in password, and that's annoying. So now you can access everything in there, and you see there's some basic stuff that I've set up since I've had my computer. Anyways, you can do cd /dev, and you can ls. You see there's this. In this case, we'll go into test and ls. You see there's the two things I set up in the new virtual root directory, right? So here's where having a system set up with this can come in handy. So you can see we have dev and home. So we'll cd into dev and ls what's there. There's nothing there. But say we wanted to understand how to use Linux in some way. Then we could mkdir, which is the same thing over here when I right-clicked and created a new folder. And we can call it, like, say for example you wanted to compile your Linux kernel. You could call it kernel. And so once you have kernel, it's there. And then once you log in, say we cd kernel, there's a tool that's very useful called wget. It allows you to download stuff directly from the command line. And sometimes this can be more reliable than using a web browser. How it works is you type in wget and then the download link. You can just copy and paste from your browser the download link directly into there. Once you do that, then you can download your kernel files and follow the directions to build your own kernel. In this case, I used a guide online, which I actually bookmarked. I highly recommend keeping things bookmarked so you can keep track of what you have learned, go through the process, and recall stuff quickly if you need to. So like here, how to compile and install Linux kernel 5.16, so on and so forth. I'm not connected to the internet. We'll switch that over right now. And now that we are connected to the internet, you might need to enable your internet if you're like me. And once you've enabled it, to be allowed to be accessed on this device, as I have just done, then you can reload it, and here we are. According to this, it gives like certain directions. You see wget and then the address. So you'll want to use apt if you are on a Ubuntu-based distro that uses apt get install, and then the name of the command you want to install. In this case, wget. And if you do that, in my case, it's already installed. So if we typed this in over here, it would download that kernel. Now, one of the things to note is if you also take this address, and let's skip off this last bit here. We'll just type in this right here. When you open it up and paste it right here in a new tab, you see a list of options. So in this list of options, at the very top, there's this. This means go up a directory. And that is because if you do cd ... then it'll go up one directory. And then we can cd back into that directory, and we're back in that directory. Alright, so now that we're here, we see there's multiple different versions of the Linux kernel that have been made. You can click on the latest one, and we can scroll down and see what that is called. In this case, it says, let's try, for example, there's 6.1, 12, 2, we could try 6. Yeah, there's a lot of different versions because it takes a lot of effort, but they're all cataloged, so you can go to any version you so like, you so choose. Here, this is the last version of the 6.7. So on and so forth before it went to this and to this one. That'd be a nice place to start. So we see there's a bunch of different files. 3 of them. There's a .gz, a .sign, and a .xz. This is a different compression than this one, but let's follow the one that's used in the tutorial. So essentially we're redoing this such that it's up to date. So we see that it is called that, right? 679. We had to switch to 6x right there. So according to the tutorial, it says to go to this address, in this directory, in that directory, this directory, and v5.x. According to here, we're at 6.x, so we'll modify that when we copy this. We'll just copy it over, right? We'll paste it, and then we can use our arrow keys to navigate over to where it says 5x and switch it to 6x. And then since we want that other one, we could change this to 6.7.9. There we go. We changed like 3 things. And then we do know that that file is there. Let's confirm we got that right. Linux 679 tar xz, Linux 679 tar xz. We did. Now, you see it's going to start downloading the file. And when it downloads that file, we can watch it, and it's downloading the file this way. Now, it's downloading fairly quickly for me, but let's go back to the tutorial while that's happening and see what's next. It says we'll need to extract the tar file. So To do that, we need to use either unxz or xz. Depending on your system, you might have one or the other installed. And here's another thing to note, we're going to want to update the name to the one that we're downloading. It says that it's completed, so let's go ahead and do this. How we can do it is we can do ls, we see the file that's downloaded, so we can type in xz-b-v space, and then we're going to want to type in what they have here. So we'll just copy it verbatim. Linux-5.16.9.tar.xz. But we'll modify it to reflect the name of the file that we actually have. So we'll change that to 7, and we'll change that to 6. And then what it'll do is it'll extract from the xz file the tar file contained within, which in this case, the process is nearly complete. Next, we're going to want to download the tar.sign file that we saw in this as well. See? tar.sign. So we'll want to download that one next. So we'll use wget. And here's the cool thing. Instead of having to copy this over and modify it, because we're using Linux, we can just use the arrow up key to the previous one. Depending on if you're using bash or sh, this may or may not be available for you. But in my case, I'm using bash, and it is. So we come up here, and we see tar.xz. We can delete the last two and type in sign. Once we have done that, we'll hit enter. It'll download that file, and we see that it is now here. The xz file disappeared once it unzipped, and so that is all normal. Now we can use gpg, which this has a list of things that we need to install, tools that are useful, and it says to install those. But yeah, gpg is one of the apt-get install gpg. It's one of the things you're going to want to do. So we'll make sure we apt-get space install gpg. Now since we're signed into root, we don't have to type sudo, which can be a bad habit, is if you're always typing in sudo, it gets you in the bad habit of using root all the time. If you're going to be doing a root operation, you might as well be signed into the root profile. Okay, so that's already installed, as you can see, meaning the command is there. So we can type in gpg, Control C to exit out of that because it thought we were trying to type in message and encode it. So anyways, we type gpg -- verify space, and then so we're going to want to type in the same thing we had here. It is simply faster to hit the arrow up key 2 times, select the bit here, right click and copy it, right? And then we get the down arrow key to where we were, 1 up from the bottom, leading us back where we were, and then we can type in Control V. It won't work if you're on this distro, but you can right click and paste, delete off the extra, and voila. Once this is done, it assumes that and shows you the RSA key right here. You right click, copy that according to this, and you type in gpg, so gpt -recv-keys space, right click, paste. Make sure there's none of those extra bits. In this case, there isn't. And hit enter. So previously, when we did this, it got the information and used this key. Now, it may or may not be able to download the proper thing. It looks like can't check signature, no public key. because of this. Now over here it says key new but contains no user ID and skipped. However, according to this, no ultimately trusted keys found, different. Alright, so there's different stuff. You would have to set up the proper things for it to do it right. But in this case, it's okay. We can continue along. So we'll GPG. The main thing you want to make sure of is that you do that process and see what the output is, because that's good to take note of. So GPG double dash verify space, and then of course we can use the up arrow keys to find that file, select it, right click, copy, down there all the bottom, one up from it, down, back to here. Or actually, since we already did this command, we don't need to. Do we? I suppose we do need to again. But we already ran the command, so we can just use the up arrow keys, find it, and hit enter. Scroll down here. Next, it's going to tell us to untar. At any rate, so we'll select this. Let's understand the command a little bit that we're going to type in. But first we're going to type it in here, hit enter Control C. That'll cancel it if you didn't already cancel. That is one thing you can do to make sure that when you hit the up arrow key, it's there, ready to be modified to your liking. Not necessarily a recommended practice, but if you're a new user, sometimes you can use that. That untars the file. Okay, now since we've done that, let's understand what tar is. So we can type in man space tar. Alright, and it'll show us all the stuff about tar. Now there's X, V, and F. So let's find tar-X. Okay, let's find more information on that. Let's go with, okay, so F. Extract, yeah, okay. So scroll down further. These are not always written in a way that's super easy to understand. But eventually you get down to here, and it tells you what each dash thing does, right? So we're going to come down to X, and we see X tells it to extract the file. Let's see what V does. Alright. It's going to be maybe further down? I don't know. Oh, here we go. Since we're... just keep scrolling, eventually you can find what the V does. And then you can find what the F does. F tells it to overwrite what's there and make sure it all unpacks. V has its own thing that it does, but it's standard to do XVF. Alright, anyways. And then we'll try Q to quit. Out of that, anytime you need to figure out what a command does, you can just type in man and the name of the command. For example, GPG that we used earlier, Q out of it, and so on and so forth. Now, we see that there is this file here. So we're in dev, we have the kernel that we're building. We see that there's the sign file we downloaded, the unpacked XZ file, and the unpacked tar file, which created a folder of its own. So we're going to go to ls, see those three that we just looked at. We'll cd into Linux dash, and we can hit tab, and it'll autofill it for us. And now that we're in there, we'll scroll down here and look, and we see that's exactly what he did here. Now what we're going to want to do is copy a certain file from our running installation that we are on. In this case, what we'll have to do is come back over to test, the root profile, and so there's going to be another folder there, and it's going to be called boot. Okay, and in the boot directory, there's going to be a folder called grub, and there's going to be some other config files. I will go to my system and show you what I have on mine. So we'll come over here to here, come into the boot, and we see that there is config right there. So we'll copy this and paste it right there. So that way when we do this, it's done proper. Okay, so we come over here, test dev, and yeah, so in test, we've got our boot directory, we've got our dev directory, which has the kernel we are building. We have the Linux right here that we've cd'd into. So what we can do is follow this directly, but we can also do it manually. So we want to cp-v, which means copy, and paste this file right here to the current directory, which is what this says, with the name .config. So, well, we will go ahead and do that. Any number of ways to do it, but one of the ways is you come over here into test, go to your boot directory, and right click and copy and paste the file directly into here. This step is standard, but it's not actually technically necessary. It's recommended, however. So that's exactly what we'll do. But we'll do it my way, since this is my tutorial. So we'll cp space, and we'll make sure that we do -v, which means verbose. It'll tell you what it's doing. We will drag and drop this from the command line onto there. We will space, delete, to get rid of the whiteness. We will back out of there. We will go to dev, kernel, and we'll click on this directory, and then click, hold, and drag it over here. And then we'll hit the right arrow, left arrow, and then we can do, once inside the bracket, slash, and then .config. There we go. It has been copied. Now according to this, once we have copied the config over, and it'll show the example output, then we will continue down, and it says we're going to want to make sure that we have this installed. In this case, you can simply copy and paste, or just type it in manually, what you see here from the terminal that he's showing that you should type into your terminal. And once that's done, I won't do it, I'll skip that step, because I already have those installed. And it shows how to do it with other distros as well. Then we're going to keep scrolling down, and we see make menu config. So we will type in that next. Make menu config. But we don't have to type that in, but it is recommended to. Make menu config. And we see that it's going to build that. So it's going to follow, what it's doing is if we go into here, we see the make file, and then kconfig, kbuild. Basically, it is building the file that we downloaded, which would be right click, show hidden files, scroll down, .config. So it's configuring what is inside of this file, because that file, it tells the other files how to build your kernel. So we can use the arrow keys and the other keys that it talks about up here, which would be Y, N, so on and so forth. And we can go through here, and anytime we wonder about what it means, we can use the arrow keys to help and read it. And if you don't understand it, you can Google what the definitions are, so on and so forth, and just read and understand and learn what each thing means. Okay? And the nice thing is you can come through here and you can tell it all the specific things Like you can go to the timer subsystem, and you can tell it to use different things, how much skew you're going to allow, and so on and so forth. Use the arrow keys, exit out of that, exit out of that. You can tell it whether you want a 64-bit or a 32-bit kernel. Depending on what you select here, it can cause it to either successfully compile or to fail to compile. By default, it should be set up how it needs to be, so we can exit out and not bother to save the changes for this particular part. Scroll down to the next step, and we can just type in make. Now, one of the things to keep in note is if you have a computer which has, as on here, we can go to system info, and we see we have 4 cores. So we can do make-j up to 4 cores. Now I like to do 3, 1 down from that. And then it'll tell it to use more resources to compile that kernel just a little bit quicker. Hit enter, and voila, look at that, it's doing stuff. In your little project that you're compiling, you could do anything you want. So it's going to go through and compile everything according to the options that you set before. It might ask you some yes or no questions. In my case, I've already configured it pretty well. So we're going to be able to allow it to do that. Now this might take a very long time. So we're actually not going to finish it out. We're going to Control C and cancel it. And we're going to go to the next step. Nproc means it would read proc and do that. We don't need to do that since we did it manually. Next would be sudo make modules _ install. Now it should be noted, this is not the most efficient way to do this. As I found, we can come over to computers, kernel, where I have a couple different things. Here we go. A good thing to have done is come down here. Here we go. This right here, su-c make mod strip install, modules install, and make install. This is what we're going to want to paste into here. Once that completes, if it completes with no errors, which it likely won't, in which case you're going to want to be able to access the, for example, a common error that is run into on a fresh install is this one right here. Is it'll say no rule to make target. In that case, you're going to want to follow this guide here on Stack Overflow, which is titled Compiling Kernel Gives Error, No Rule to Make Target, and this file right here. Alright, that's a very common error that I notice on a fresh install you might encounter. So you're going to want to come to this guide and scroll down and follow the different steps, which in this case you can follow this right here. So user local source Debian, right? So we'll come over here and we can do that. So we can come over here and go to new tab and paste that right there after we cd into the right location, which we can see we are in dev test dev kernel. So we can copy this, come over here and cd control V or right click paste, delete off the extra, hit enter, voila, we're in the same directory. Su to give us root access privileges. Actually, you can do it either way, but yes, we will do it this way. And then we can right click and copy this after we cd ../../, which will go up from this directory and then dot dot slash to go up the third directory. 3 directories up, we can copy and paste this in there, and we can ls, and we see that we should have ls-a. Oh, actually this would be, in this case we're going to take this slash off, and we can now ls, and it created the user directory right there. So next we can do apt install Linux source, and paste that in there. And once that is installed, in my particular circumstance, we're going to come over to exactly where it has user local source Debian. So this would be user local source Debian. I'm going to copy that file over to our mini little version of a local file system. And since it's not, the stuff isn't in there, we'll paste this, merge the files. You probably won't have to do this bit because you're working as differently than I am. Anyways, closing out of this window, now we can follow the guide as it is. So, we will go ls, and we see we have indeed got the user directory, which has the files that we need. So we will cp-v, or copy. How we would do this is we'll just do cp-v, so it's verbose, so we see, so it'll tell us if it's successful, and if it's not successful it would tell us the error, but we want to see the confirmation, yes, you've succeeded. So we'll come over here into user local source Debian, right? And it says we're going to want to place stars in the proper things. So because both of these contain the word canonical dash, we can place a star to say anything that contains canonical dash. That'll include certs and revoked certs as well. Coming back over here, Linux source, user source, Linux source, so on and so forth. At any rate, you would use this, follow this guide to copy these files right here into essentially, you can just come over to the Debian. We're going to do it different than the guide says. We're going to cp-v, and following right here, you can cp-v usr slash local slash Debian slash star. The directions may differ for you. You might follow this guide, but this is how I'm doing it. Once you have those two files in that spot, and then we will type in slash dev slash, and looking over here, we can check where we are. Kernel slash Linux lin tab ux tab. Nope, we're gonna have to go and type the whole thing out. And now we come over here and we see here, there, and it says use your local Debian, and we see that it didn't work. This may occur. User local source src. It's okay if you make a mistake, because you can always go back and keep correcting it until you get it right. Debian. In this case, since it's so specifically sensitive, we can just drag and drop that there. Take off the part I don't need. Take off the apostrophes, and then slash star, and then dev kernel Linux 679. So we'll come back over here to dev kernel 679. We'll just drag and drop that, and we can take off the parts we don't need. And we'll make sure we add a slash at the end. We'll take off the initial slash, and what that'll do is it'll make it place it inside of Linux 679. So it says it's not a directory, which is simply false. But sometimes it can be a little bit picky with the particular way that you do your stuff. And if your kernel if you're doing stuff by the command line gets annoying, you can just come over here and do it manually by going to dev kernel after you come into user local source, copy the Debian folder, come back over to dev kernel Linux 679 and paste it in here. That's ultimately what you're trying to do. So now those files are there inside of the Debian folder, inside of right here, since this is a Debian source built distro. And the next thing you're going to want to do is you have the ability to remove all the extra files that you didn't need to be able to put that into here. Closing out of that, we now know for a fact that we have the files here that we're going to need. And we can close out of the secondary tab that we had, and we can run this command, and it should run without error. So we've made the kernel, we make the module, strip1 modules install. What this does is it makes the parts that complement the kernel to make it run, and this actually installs the file onto your Linux system, and then you'll be able to select from grub bootloader, which is what a lot of Linux systems use to finish the installation of the kernel. Now, I have a lot of tabs open. Some people do. There's some tabs I like to keep open as projects that I have not finished. It's a good way to keep track of something familiar across everything you're doing in Linux. It acts like a bookmark. So it also keeps certain applications running in memory. This can be a useful tool to keep the distro running how you want it to. Experimenting with different ways the kernel compiles can help you find the Linux, the kernel that'll make Linux work for you in exactly the way that you want it to work for you on your particular system, made for your specific hardware. Coming back out of here, we can come back over to kernel. This helps us not get lost in all of the different possibilities of how things could work and keep on track with where we are. So yeah, once you've done that, it should have installed, and if you reboot your computer, and this is actually your root file system, not a subdirectory inside of your root file system that I created to demonstrate this concept. And you've done all of this, then you should have successfully been able to use files from your boot directory, files from the internet, and files that you created inside of a secondary dev directory with a case-sensitive uppercase D to build a kernel under a custom folder, which you name whatever you want. And when you go through your kernel, you can set the kernel to have a custom subname if you go through the documentation. And you can put the name here so that way it matches that, and it'll be a nice little project that you have. And then your system, once you reboot it, will be running your custom kernel, running how you want, and you will have directories available to compile new projects in, or you can also use it if we say chroot. You can make a chroot folder, and then you could come over here down to clearing this out. We can ls, we are in there, so cd // 3 times. To go back out of that, test ls. And so you could cd, or what we could do is mount /dev /chroot is going to be where we're going to mount it to. And the one that we're going to mount, well, we come over here to disks in the Mint menu. You can launch it here or launch it in terminal, either way, in a new tab. We see there's multiple options. We can come over to somewhere and find an existing system, for example this one, SDB8, so we could do, like, for example, /dev /SDB8, and that is the root partition. So we come over here and we'll mount it to the chroot. Dev /chroot doesn't exist. It actually does, but not in the way that we wrote it. We'd have to take the slash off, so that way it checks from the existing directory we're already at, not from root, in my case. In your case, you might be able to use the slash. So once we've done that, now we come over and look in chroot, and that partition is now mounted right there. And then we can mount its home directory, for example, which would be SDB9. So we would go change it to 9 and change the end of this to be /home. And then we could ls, and we see that it's still the same as it was, but we can also cd to /dev /chroot and do it proper. So we could just type in d e tab and then ch, or just c tab. It'll finish it out for us, and voila, we are in the chroot directory. ls, we see the full file system for that chroot, and then we can mount /dev, lowercase dev, to squiggly slash, or to literally just dev in the current directory. So mount the root dev to the current directory's dev. See? And it's going to give that error because we need to remember to add --bind. So it'll bind dev to dev, meaning it creates like a bridge. If you're an entrepreneur, building bridges is your thing, this would be a great symbolic link to bridges. So you bind dev to dev, and then you would also want to bind sys to sys. Say you had Linux installed on more than one hard drive, and maybe one's an external one, you could do this to your external hard drive, and here's what it would do. Dev slash PTS, and then once you've mounted those three, in order to give your chroot internet access, /etc/resolv.conf space etc/resolv.conf. Right? So now you've essentially, this file configures when your system boots, and it updates when you update your internet connection to point your system's ability to connect to the internet to your actual device providing the internet connection. So this copies that files over to there, so it's like the system had just booted and it's synced with your system's existing state. So the next thing we would do is we would chroot dot, or the nice thing too is if you say you were doing stuff and you just were around your file system, you could just at any point type in su and your password, if you typed it incorrectly, and then you could cd/dev/chroot, and you would be in your chroot. Now, it's saying that because ls, we went back to there. So cd/ls cd/dev cd, we'll just ls there. What did we call it? Oh yeah, cd test ls, and here we are. So we can chroot, since we're already logged in as su, and we could do dev/chroot, and look at that, we are logged into, let's go back over here, we have actually, inside of the dev directory we created, and the chroot directory, which is next to the kernel directory conveniently, we can see that we have mounted that file system, and now since we've done this, we can have internet connection. We can do a test to make sure that internet connection works, and it does, because you can do apt-get space update, and when you do, it has internet connection. This means you can install applications, build packages, and all kinds of other stuff without it actually being booted up, remotely installing all types of packages and abilities into an existing system. Note that doing this might break that system from actually being able to boot, but it is something that you can do. Anyways, so we can exit out of that, ls, and we see we have the files just as we left them. All of the chroot stuff is kept neatly in its own directory. All the build stuff is kept neatly in its own directory, separate and different from the rest of the system, modifying none of its stuff except the stuff we install via apt. So then we can cd into home, and whenever you install a custom application, say you downloaded and installed Java and you wanted to play Minecraft, then you could install the Minecraft launcher and install it to your /applications folder inside of your home directory, in which case you would be able to type in squiggly line /applications. On my system, you could do ls, and inside of /applications on my system, this is what you get. If we were, because we're logged into the root directory. But if we come over here, I'll show you my applications as I have it set up. So inside of my system, inside of home and my home folder, inside of the applications folder, I have Everspace installed, RimWorld installed, Starbound, Terraria, Technic. Here's the nice thing about this. Say you install something into here. All you would need to do is create a folder named the thing you want to install, put the files all to do with that don't rely on your libraries. All these things can rely on outside sources in your system, but the bulk of this stuff should be designed so that way it's self-contained. Like on Mac OS, it's like they rename it to .app, and it's just a folder containing all the things that is that application. So you install, it gives you an option to install to a custom directory. You can set it to here, so anytime you come in to, say, your Technic folder, which has your Minecraft installation, and you want to modify the mods that are there, you're always going to the same place to do your modifications to these types of applications, which is familiar if you're used to using, say, Windows or Mac OS in its own way. And it creates a familiar environment, modifying the game files with mods and stuff. The other nice thing is if you like to run Minecraft and Terraria, and also like to run a server so your friends can join, you could create, say, for example, a server folder. And inside of that server folder, you could, say you have Sublime Text installed, take a look at this file, in which case I have it set up so it labels itself to use /bin/bash. If you execute it as a script, I chmod 777 this file so that way, or chmod plus x this file so it has executability. You can also do this by going to properties, permissions, and allow executing file as program. And then I have it so it simply CDs into the current directory that the file is currently located, which in this case is servers, and then it tells you select a server, so it echoes, it tells you to select a server, if it just echoes that line, and then an ls to show you the files that are currently in the directory, and then it read a name, a variable, and you can, I will demonstrate its functioning. So we'll come over here and execute this executable server selector, I have called it. And we see the first thing it does is it does this, ls and then read, which pauses it and waits for your input. So it lists that we have Sky Factory here, we have T-Shock here, and we have ZTF Alpha here. And so you just type in the name. For example, T-Shock. And hit enter, and it goes to the next thing. It'll cd, basically you entered it, it'll cd into whatever you just entered, and then it'll ls-a everything in there, and then press enter to begin to give you a chance to see, did I enter it, did I type it in right, did it select the folder I wanted? Yes? Okay, yeah, you're right, good. And then it executes the server start script, which is located in the folder that you would need to make for each individual server, which in this case I have set up to have this, so it'll basically launch this file, which tells it to use the same bin/bash cd into the current directory, which will change it from a previous directory, which it was servers, into the current directory. And then we will be able to sudo and then .NET run, which is why it's asking for my password, project tshock launcher, and I'll be able to run tshock as root as a .NET compilation project. And then once I enter in the password, for example, and I entered in correctly the right password, then we see, and it's always noted that sometimes having the wrong password entered initially will tell it to operate in a different mode of security because you entered the password incorrectly one time wrongly. It changes its mode of operation. That may be something you find to be useful if you're running like a server. It makes the server run in a slightly different permission level because of the way sudo executes its files. Anyways, then you could select a world and it'll load it. And then say for example you're done, you could, or in my case, I actually will be using one of these worlds. So I'll just hit in 1 and enter, and it'll load up Terraria. Voila! I have my Terraria server, it's good to go, and able to run. So in server activator, then at the end of it, it gives me a chance to read if there were any error messages during executing this program, So basically at the end of this, say it errors out and it auto closes, that would auto exit that, but it would still get hung up at this one, so I'd have a chance to actually read it. So I could say, for example, diagnose if it had a problem or not. At any rate, the server has started. And I've done this in this way because it can be run more than one time. You can run more than one server at once, say for example all 3, and people can join your worlds. At any rate, having it all stored in the applications folder gives is just something I found more natural to me in the way I use Linux. And having this is kind of convenient way to start servers. So if you're like me and use servers, you have permission to type this out on your own and type this out on your own or whatever, since I don't have the files included in a Git or something like that yet, to be able to make your own version of what I have done here. So that is how I have my system set up so far. And it seems simple and easy to use for making YouTube videos. I've got GPU screen recorder, and that is the end of the video. I hope you enjoyed. I hope this is useful to you. Go ahead and post comments. If there are more efficient ways to do it, go ahead and post those. Of course there will be. But having an inefficient way shown that directs to more efficient ways can also be a useful mode of teaching or learning, and so on and so forth. So, have a good day. Bye.